Alright, today we're going to talk about Chapter 1, Section 4, which is manipulating formulas. Manipulating formulas is just a fancy way of saying solve for a given variable. A lot of different formulas have multiple variables in it, and we're just going to isolate one. We're going to just start with a general linear equation, and this is a linear equation in standard form. We've got 6x plus 3y is equal to 15. What we want to do is we want to solve for y, so we just want to isolate that variable. First, we have to move the entire 6x term to the other side. So you know to add the opposite. So if I'm adding 6, I'm going to subtract 6. That leaves us with 3y is equal to negative 6x plus 15. And we're almost there. One more step to get y by itself. So I have 3 times y. The opposite of multiplying is dividing. I'm going to multiply or divide all 3 terms by 3. So I've got y equals a negative 2x plus 5. Number 2, again, we are going to isolate our y term. Before I can break apart the negative 4 from the y, I've got to get this entire term isolated. So I want to move the x term over. So I subtract 1/8 x from each side. That cancels. I've got negative 4y is equal to a negative 1/8 x plus 20. Since I'm multiplying by negative 4, to move it to the other side, I divide each side by a negative 4. That cancels. I've isolated y is equal to a positive 1 over 32x minus 5. So you can see that we've changed our equation from standard form, and hopefully you remember slope-intercept form. So taking the equation solving for y, I've changed into slope-intercept form into graphing form. Alright, for our third one, hopefully you're getting used to this by now, what you want to do is press pause, and I want you to try number 3 on your own, and I want you to isolate y. Once you've got your answer, press play again and see if you're correct. Alright, so the first thing I did was move the 7x over by subtracting to both sides and then dividing each of my terms by a negative 3. Now, some of you may have thought you got it wrong because you're used to always having whole number or integer answers. Just because you get a fraction doesn't mean you're wrong. Get used to seeing fractions in really large numbers, really small numbers. If you also had written down y equals a negative 7x plus 8 all over negative 3, technically this is also correct, but I would prefer for you to write it in this form. Here, the only reason why it's correct is because you can't reduce anything. The 8 and negative 3 doesn't reduce. The negative 7 and negative 3, the only thing you could do there is cancel out the negative. So this technically is correct, but I want you to get used to writing it in this form, just that way you don't forget to reduce any of your fractions. Alright, so that was graphing, that's linear equations. Now we're going to move on to some formulas. For number 4, we're going to use the formula for circumference, and we're going to solve for pi. Circumference is a formula that you should be very familiar with from last year. Hopefully the summer has not made you forget the circumference is equal to 2 pi r. The very first thing that you want to do when you are solving for anything is identify that piece. So I want to find pi, or I want to isolate pi. On the same side as pi, I've got a 2 and I've got an r. That means that if I want to get pi by itself, I've got to move the 2 and I've got to move the r. This one is actually easier than it looks. I have 2 times pi times r. Since I've only got one term here with 3 pieces, one term and the 2 and the r are both being multiplied, I can move them in one step. The opposite of multiplying by 2 is dividing by 2. The opposite of multiplying by r is dividing by r. So I'm going to divide both sides by 2r. And again, I can only do this in one step because I have one term. If this was 2 pi plus r, I wouldn't be able to do that. 2 divided by 2 cancels. R divided by r cancels because we know regardless if this r is 10 or negative 500 or a fraction, anything divided by itself is just going to become 1 and it cancels. So we've got pi is equal to c all over 2r. And whichever variable you're solving for, you want to write that out first. Number 5, using the formula for area of a triangle, you want to solve for h, which you know is the height. So first we've got to start with the area of a triangle formula. We've got a is equal to 1/2 base times height. And we want to solve for h. Now technically, just like the last problem, we only have one term with 3 pieces, so we could do this all in one step, but I want to do this one in 2 steps. Generally, when I have a fraction, that's the very first thing that I want to get rid of. And to get rid of the 1/2, we are multiplying by 1/2, so probably your first instinct is to say, okay, we're going to divide both sides by 1/2. We don't want to divide by fractions. Dividing by fractions is just going to make things a lot more complicated. So one rule of thumb that you always want to remember is dividing by a fraction is the same thing as multiplying by the reciprocal. And the reciprocal is just flipping the top and bottom of the fraction. So instead of dividing both sides by 1/2, I'm going to multiply both sides by the reciprocal, which is 2. So that gives us 2a. 1/2 of 2 it just gives us 1 is equal to b times h. And h is still what I'm going to be solving for. We're going to move the b. I'm multiplying by b, so I'm going to divide both sides by b. The b's cancel on the right, which gives us h is equal to 2a all over b. And our last problem for our 1-4 notes. Number 6. You have 40 feet of fencing for your rectangular garden. Express the perimeter in terms of length only. Alright, so got a word problem here. We're going to pick out the important information. You've got 40 feet of fencing, and I see that I have a rectangular garden. We want to talk about perimeter, and we're going to solve for the length. So the first thing I'm going to start with is the perimeter formula. Hopefully you guys know that in order to find the perimeter, you just add up all the sides. Well, the fact that I've got a rectangle here is going to give us a special formula. The perimeter, since you'd have a rectangle, you know that opposite sides are congruent. So you're going to have 2 lengths and you're going to have 2 widths. So just in case you're confused on where that's coming from, you've got a rectangle, doesn't matter what the side is. Let's say this is the length. That means that that must be the same because the opposite sides are rectangular congruent. This is my width, and if this is my width over here. So if you add up all the sides, you've got 2 L's and 2 W's. Now what I know is that I want the perimeter to be 40 because I've got 40 feet of fencing. So the P is being replaced with 40. And I want to express the perimeter in terms of length only. That just means I want to solve for L. So this is my variable that I'm going to isolate. Unlike numbers 4 and 5, I don't have one term on the side with my variable. I've got 2 terms. 2L is a term and 2W is a term. So this is more like questions 1 through 3 on your notes. I want to get L by itself, but in order to get L by itself, I've got to move the 2 and the 2W. Before I can separate the 2 and the L, I've got to get this term moved over. So I've got to subtract 2W from each side. That's gone. Over here, I've got 40 minus 2W is equal to 2L. Now I can't combine those two pieces because they're not like terms. This is a number and this one has a variable. And I've only got one step left. I have 2 times L. So the opposite of multiplying is dividing. Remember that you're going to divide each of your terms individually, not L as 1. And that cancels, leaving us with L is equal to 40 divided by 2 is 20. Negative 2 divided by 2 is a negative 1W. And if you had also written it as L equals negative W plus 20, that will also be correct. It doesn't matter if the number or the variable comes first, just make sure that that negative sign stays with the W and the 20 stays positive. And that's all for your lesson today on how to solve your equations for different variables.